Here's some tips when using U-substitution. The best choice for U is usually a radicand, that's the part underneath the square root, the denominator, that's the part underneath a fraction, the base of an exponent, or the exponent of an exponential. We'll also add the more complicated part. The second tip is you need to find the derivative of u, which is the derivative of f of x dx. Don't forget the dx. Multiply or divide du by a constant to make it match the remaining part of the integral if necessary. That's what we did in example B, part B. After the U substitution, make sure no factors contain x. If they do what we did in example C, part B. Then after you integrate, substitute the expression for U back in. A company determines the marginal cost. Now remember, marginal cost, we find it by taking the derivative of the cost function. So the marginal cost for producing computer chips is MC of x equals 6x times the square root of x squared plus 11. The company also knows that it costs $1,932 to make 5 computer chips. So that means when x is 5, the cost is $1,932. So in part A, they're asking us to recover the cost function. They are giving us the derivative of the cost function. So we want the antiderivative or the integral of 6x times x squared plus 11 to the 1/2. I'm rewriting that square root dx. Let's let u be that inside part or the radicand that was underneath the square root. X squared plus 11, which means the derivative would be 2x dx. Now, notice we don't have a 2x, but we do have a 6x. Well, remember, 6x is the same thing as 3 times 2x. So we can rewrite this integral as 3 times the integral of 2x times x squared plus 11 to the 1/2 dx. The only pieces past that integral should be your u and your du. So now we can rewrite this integral as u to the 1/2 du. And let's take the antiderivative of u to the 1/2. So 1/2 plus 1, 2/2. That would be 3/2. So dividing by 1/3/2, let's see, gives us 3 times 2/3 u to the 3/2. Which is 2u times the square root of u plus c. Let's plug our u back in, which means our cost function would be 2 times x squared plus 11 times the square root of x squared plus 11 plus c. But we need to know what that c is. Remember, they gave us a point. When x is 5, c is 1932. So let's plug those in. So the c is 1932 equals 2 times 5 squared plus 11 times the square root of 5 squared plus 11 plus c. And then simplify. So we get c to be 1,500. So that means that our cost function is 2 times x squared plus 11 times the square root of x squared plus 11 plus 1,500. Now in part B, they want us to determine the fixed cost. Well, remember, the fixed cost is how much it will cost the company even if they make no products whatsoever. In other words, when the number of computer chips is 0. So plugging in 0 for X, it gives us approximately $1,572.97 of fixed costs.